Yeah, dude, I'm fucking smoking all the time. Oh, great start to a stream, I guess. Let me... Oh, you know what? Because this is this way. So I'm right now. You get to see my other half now.
Oh, God.
Yeah, I know, right?
Who says that?
Me, bitch. Oh, I gotta be nice to you. Okay. Yeah. Ooh. Disconnect the camera. Okay, it's what I do best. Okay, there we go. Yeah. And, I'm just gonna turn on this light. Yeah, cool. Sir. Oh, well.
Do you need to see?
What? No. No. What? What? I'm so confused. You know I never work with my glasses on.
What?
Dude, I never look at computers with my glasses on.
What?
Never. Ever. Ever, ever, ever. It gives me headaches.
I am distraught.
I never do, dude. Like, I have zero issue seeing something, 2 feet in front of me. Oh, so look at this stuff. So these were my old results, right? These are my new ones.
Okay.
So the differences are mainly this right here, this connection around the Yucatan and into what is the Panamanian Isthmus? It's I forget what it's called, but like it's capturing a north-south split, or more accurately a Pacific-Atlantic split, that I have not been able to recover in anything, like in any way, which follows Savage's stuff, the original shit. Uh-huh.
That's great.
Only weird thing, though, is these regions down here now are not splitting out as much, and we're getting some weird little islands effects, which I think might be geography, like my geographic data set, because I know I need to fine-tune it a lot. But I got it. Also, I am so fucking happy I segmented out all my scripts, because in doing so, when I updated the phylogeny, I only had to load in this data, change a few words, and then just save it. Like, I didn't have to rerun anything.
Right. Huh.
Yeah, like, because I realized I was like, oh god, I gotta do all the combinations of GBIF and IUCN data, but I don't.
Right.
At all. Like, it just, yeah, it's made a huge difference. But, yeah, I need to start up some post-hoc things, so... Yeah, okay, so let me just double check what the biodiverse software needs. And I probably have scripts to do this, but I want to remake them. I've shown you biodiverse before, right? The software biodiverse?
I don't think so.
I've mentioned it for sure. Okay, let's just look at the quick start guide. It's basically you would actually really appreciate it. I just need to figure out the data structures. That's what I want to get to. Okay. Okay, base data is the primary storage object. 1 groups, 1 labels, parameters. Okay. I mean, I don't need this actually because it's all right here. Okay. Labels. Labels being an element typically they represent species. Okay. That has been collected. Number of axes. Language, digit, taxonomic order, or some other hierarchy within the labels. Okay. Groups. Special type of element. Groups are square cells into which the labels are aggregated or binned with differing cell sizes. Okay. These are a tree object, but also store the matrices. The terminal nodes have the name of the relevant group used to link this. Okay, we got the trees. I might not need to. Okay, wait a second. Right. I need to make this thing. Okay, I need to make the base data. That's what I'm doing. Okay. I was struggling to remember. Okay. But wait, then why can't I have a cluster? Okay. Normally they are linked to the labels of a base data object. They are also used in cluster. Previous uses include genetic similarities. Okay, well let's open up Biodiverse. Maybe that'll be the easiest thing to do. Which I should have it in my documents. Yep. Okay, Biodiverse. Yeah, and maybe I can actually show you a little bit about what's going on. So, yeah. Okay, but wait, so I need base struct, set of elements, one groups object, one labels object, and a set of parameters, and one or more cluster. Okay, so yeah, I do need to make, this is just my presence absence matrix. Okay. Oh, no. Okay. Base data matrix and tree object data. Base data can import from text files. One record per observation. A list with one line for each species coordinate combination. This is the common data format. A matrix of data with coordinates as the rows and species as the columns. For example, a site by species matrix. That is what I have. The value of each field is the count of observations for that site. Okay, so I need to make this. Okay, so let's start off with base data. Need a 2-column matrix that is that is species and site. This is this is graph theory stuff. This is a edge matrix. Okay, so convert presence absence to edge matrix. I don't know if that's the right thing. A distance matrix. Edge list. There we go. iGraph does it. Okay. Get edge.list. Yep, perfect. Okay, easy enough. Don't even have to do anything else. iGraph, and then p is equal to, okay, presab. So this should be graph dot adjacency. And then we have edge is equal to get dot edge list p. Cool beans. Oopsies. Okay. So let's do install dot packages. iGraph. Easy enough. Error install. One or more packages is currently loaded. Wait, no. Thought I had an error. Oh, did I? Hold on. Graph dot add adjacency. Error, non-square matrix. Well, duh. Oh, or melt. Will that just work? Reshape melt. P. Is that right? It is right. Wow, done. But then we need to just select x1, x2, and then we need to summarize it where we want it to be the species is equal to x1, and then we want it to be cell is equal to x2. Errand function select for a data. Excuse me, sir. What? Oh, this happened. Dplyr. Did that work how I wanted it to? I think it did. It did. My tidy skills have gone through the fucking roof, dude. Like, I'm fluent in tidy now. I feel so good. Okay. Okay, so I got the base data. Then we have the tree will just be philo. Okay, cool. It needs to be in Nexus format.
That's fine.
Or .tree format.
That
So
could be easy,
right
yeah.
dot Nexus, it's dummy, easy. Philo,
What package are you using?
ape.
Oh, yeah, that makes sense.
Yep. File is equal to outputs, biodiverse. I'm just gonna call this BD, I think. Just start them all with the prefix dot tree. No wait, we're doing a Nexus file, so we dot nex. Okay. And then we can also do here write dot CSV. It will be P, and then the file is equal to outputs BD. You can also like ask any questions during this.
I know. I'm
And-
doing my own content.
Okay, I know. Like, I definitely want to talk too. If you want
Right.
to, if we want to, like,
Yeah.
any time you can interrupt me is also what I'm getting at.
Yeah, I found this cool article that's talking about incipient species on Hawaiian island woody species of plant.
That's perfect.
I know, and that's what I'm like.
I told you like
cool.
that's the angle you need to go down.
You're right. I know.
No. I mean like half, like more than half of doing research is figuring out what to fucking Google. I mean, like you saw me. I've been stressing about this shit for weeks.
I know.
And
then you just start Googling.
I found it. No, I found the right thing. Like
Right.
it was like the right terminology, the right angles, and then boom, finally fucking found it. Did it in a few hours. Like, oh wait, what is this? Oh, .csv. Okay. Okay. actually saying to use right.table, so I'll just do that.
This is the weirdest.
And sep is equal to. Okay. Allowing labels, no groups. Allowing empty groups. Both empty groups and no labels option. The skip lines. How many columns should all be treated? Data matrix form, data not matrix form. Like this. Select one group. At least one group. At least one label. But more than that. For example, you choose a species column and a genus column if separate your file as one combined label for your data points, or to specify both the x coordinate and y coordinate columns in a file as a group. Specify a Cartesian grid. Oh, wait a second. Okay, so I need. Okay, so what I need to find is. So my presence absence matrix has those grid cells, which are found in the occurrence data set. No, found in the polygons data set. But matches com phi. Okay, no. Raster. Okay, so coordinates. SF. What is it? Coordinate? Is it ST coordinates? Raster. Boom. So those are those chords.
Add.
Okay, wait a second. You have done this to yourself. It's rather embarrassing. Okay. So one of these. 1, 2, 3, 40. One of these has got to be the center. No, because they're drawing grid cells. Wait, unless. SP coordinates raster SP. This might be better.
Ooh, so pretty.
It is not better. I think. Okay, wait. So. Oh, okay, so yeah, I just need to get this for the coordinates. And then, okay, chilling. Okay, get those chords. So then, chords, and then we merge P and chords by dot x is equal to, okay, we'll do that, and then we will mutate ID equal to row dot names. Wait. Is equal to. Wait. It should just be ID is equal to.
This is so cool.
Explain it to me.
Yeah, this paper is looking at this species of like within the crepe myrtle family, which is like eucalyptus.
Yeah.
And they're looking at it across 3 different clusters, which have been determined to have 3 distinct clusters
Right.
according to their environment. Which makes sense. And so they actually exhibit substantial genetic and phenotypic diversity, which is cool. They show signatures of selection in genomic regions encompassing genes relevant to environmental adaptations.
Okay.
Including genes associated with light utilization, oxidative stress, and leaf senescence when they drop their leaves, which are likely associated with ecological differentiation of the species. Cool.
And then could not find Mirig. Base data. Find out why. Okay, then how does this look? It looks, let me just make sure it changes when we hit number 2. Or when we change any number. Should work, but I just want to double check. Okay, where does 37 turn to 40?
Oh.
Oh, there we go. Oh my god, why does it keep jumping? Ah, finally. Okay, they're different. Cool. Okay. Okay, so we got that. Cool. Done there. Nexus is done, so now I can actually add in the coordinates, which is all good. Okay. Oh, you can add more data. Okay. Base data. And then we're going to do it. And then what is it? Rename. I'm just going to say names of base data equal to C, and then what is it here? Okay. Grid species. Grid species X and then Y. Cool. So now anything can be based off of this. Okay. Cool. Perfect. Matrix data can be imported at any time. Same way. Base data files. One one label column and a matrix start. Any other columns fail should be set to ignore. This thing is just like really, this tutorial is awful though. Like, it's just not clear what a matrix data is. It's not clear what each data can be and what the best way to do it is. So I always kind of struggle with this. So like a cluster, for example, like how is that imported as a matrix? Or do I add that onto the thing? Also, it never started, so I'm a little confused. Or wait, was there a thing where I had to run it as admin? No user-defined extensions. Perfect. Yeah, I just had to run it as admin. Okay. So let's create a new project. I think it created a new project. Base data import. Or sorry, tree import. Use tabular tree format. No. Okay, so we need to go into Google Drive, My Drive, OneDrive, Research. Wait, where the fuck am I going? Oh, it's just at the top. Oh, no. Okay, so we go to outputs. No. Okay, let's export these two really quickly. Write.table and write.nexus. Let's need to text.
This is similar to what Alex's stuff was, her thesis.
Oh yeah.
It's showing that there's varieties of this species, and that
Varieties?
Yeah.
Is that like a technical term?
Kind of. So it's hard to differentiate between
So what you're saying
varieties and subspecies.
So what you're saying is that indica and sativa are different species.
Wait, they are, aren't they?
No.
No, they're varieties? God damn it.
Strains, varieties.
Okay, yeah.
No, I mean, like, they all use it wrong and it pisses everyone off.
Yeah. I'm like, wait, what?
Yeah.
Yeah.
Yep.
So some of the varieties have intermediate morphologies, suggesting that hybridization between varieties is common in the species, and reproductive isolation between varieties is likely to be incomplete.
So how can you have varieties?
How can you
Are they
have
not
varieties?
just like on a an isolation by distance spectrum, or?
No. Well, I mean, in this case, no.
I'm just saying, like.
Right. So far, the authors have introduced it as they have different morphologies according to the habitat that they are present in. So there's some that inhabit a subalpine, there's some that inhabit a dry habitat, and there's some that inhabit a more forested habitat.
Okay.
So they have different morphologies.
I just like, well, yeah. I also don't like the term hybridization. Like, personally, I just don't like the term hybridization for things that are not full species, because it's like, I just say like they're introgressing, because it's just
right,
like,
right. It implies
it's like, I'm not gonna say like this is a hybrid, and it's like, bro, that's just two different populations. Like, it, yes, I know technically it is, blah blah blah. I'm not gonna call someone at a conference or anything, but like, in terms of like what we colloquially understand as like a hybrid, I don't like it.
Right. But that's the nuance of it.
Right, but I'm like, listen, if we're gonna have a million terms that mean the exact same damn thing, maybe we should do it a little better. Remap the node names. Okay, so now let me add in the base data. Add in base data. Outputs, BD base data. Next. Okay. So, Data are not in matrix form. Convert sample counts to binary. Input field separator. Maximum number of header columns to options form. Ignore. Okay. Okay, so this is where I need to go into the documentation again. So, because also none of these pictures are working. Let me just reload it just in case it is me. Yep, none of his pictures are working. Okay. Label lists. I want to import. I'm still on importing data. Okay. Okay, so then species is my label, grid is my group.
I have a question for you.
What?
Does chromosome scale pseudomolecules mean anything to you?
Okay, so chromosome scale pseudomolecules. No idea.
Yeah, that's what I'm like. What the heck does that mean? Pseudomolecules. So
Yeah.
somewhat molecules?
Okay, sweet.
Concatenation of contigs with a small sequence between them intended to represent a larger native size molecule. Doesn't mean anything. What the hell's a native size molecule?
Latitude out of bounds.
Yee.
Oh, did it backwards. Okay, so text group, label, group and group, isLon, isLat, cell size 0.05, cell size 0.05. That should be it. Seems like it's gone. So many lines of data. Oh, this section can take a good while to load in. It's at 350,000 lines, but I think it's 3.2 million.
How about them chargers?
Yeah, how about them chargers? Think they're gonna come back to Snapdragon? What the fuck is Snapdragon? What company is that?
I told you what it was. It's Qualcomm again, but it was previously just Qualcomm Stadium. But now
But what is Snapdragon?
it's a processing thing.
Oh my god!
Like-
Duh! Yeah, I know
You
that.
said that last time.
I did too. I know. That's what I do best. Forget what I said. It is what I do best. I'm just saying. Okay.
What are your thoughts on papers that put the results at the end?
Results at the end?
I'm sorry. Methods at the end.
I know I disagree with Jeet's opinion on it.
I don't know what she says. So.
Jeet's opinion. Okay, well. Okay, well, let me think. Let me think out this. I do agree with what Jeet is saying. However, from a reading a paper point of view, okay, so basically Jeet's opinion is that by putting the methods at the end, what you're doing is making the methods seem like secondary to the actual analysis, when really the methods are incredibly important to how you get your analysis right. However, and I agree with that, that does make the method seem, because they're also in smaller text and font size and all that.
Yeah.
However, when I read a paper, I skip the methods every time. Unless I need to read the methods for my paper.
Yeah.
Or for whatever I'm doing. So, I prefer it.
To be at the end?
I prefer it to be at the end simply because the methods are such a long barrier to things.
That's true.
Like,
understanding.
I think what they do now, though, in a lot of things, is that they have an abbreviated methods in the intro of like, we used this and did this,
Right.
and it's like not specifics, and that I prefer greatly, because otherwise, because the problem is, the other option is the fact that most methods now get shoved into supplementary materials.
That too.
So you're never gonna read them.
That's true.
Like, so like I prefer them just at the end when a little bit smaller. Like, that's fine with me. Space data is almost done importing. I think it just makes it easier to read.
Yeah, it does. It does. It's not as intense.
Yeah. Okay. Remap the label names. I just won't do that yet. Okay. Base data has 2 axes, so some cells will be overplotted. Okay. So, everything is fucked up. Yeah. Oh no, my tree is fucked up, I think. Yeah, my tree is fucked up. Oh, my tree is massively fucked up. Because this is what I did today. I added these branches. So, are my units not in time? Yeah, maybe my units are not in time. Okay, well, let's see. This will be an easier fix. Okay, so let's go into my... Okay, I don't need this, don't need this, don't need this. Not that, not that. Not that. Not this. Not this. Graphed phylogenies. Okay. So, if I load in... So there must be a ape. Okay, let me look at phylorama. Ape. Estimate the dates of a rooted tree from the tip dates. No, none of the read, no depth. Is this what I want? Philo. Okay. Oh, well, why don't I do it with... Okay, why don't I do this? So philo raw a... oopsies. Extract dot clade. And then... Oh, no, wait. Okay, so these are... What are these edge lengths and what units are these in? So, units of edge length. In phylogenetics, yeah. Okay, so my time is off. Measurement of time. So convert units of edge length in phylogenetics. R. Like, I need to just double check. Okay, so there's a lot that's wrong. Okay. Okay, plot philo raw A. Be pretty big. Okay. Plot phylogeny with axis. Okay. Axis philo. Hmm. Oh. Oh. Hmm. I feel I need to plot this. I'm wondering if like my scale, like maybe these are on a different scale is all. And if it is, then I think I know what to do. Like I'm wondering if it's in like billions of years ago format instead of millions of years ago. Yeah, it's saying that everything happened in the last 2 years. So okay, philo raw A mutate or tip. Nope. No, it's edge. Let me look at a couple papers. So I need to go to the but that's I just don't want to assume that. Okay. Supplementary data can be found hither. .sc/boom. Let's see if this will just open up. Ah, damn it. Okay, it's documents. Okay. Okay. just trying to get the units. Let me try 8022. Yeah, cool. Okay, I just want to get the Appendix A supplementary material. It should be in figure. Let's check out S3. So, complete based on values besides nodes or age estimates in million years. So this is what I want. These values. Okay, so let me try to find one. Yeah. Let's pull out Tinosaur or Tenotus and Aristus. Okay. Okay, so let's just extract out a clade and double check it. Okay, so boom. So we have Tenotus. Hilli. Let's look at this one. Okay, Tenotus, Hilli, and then Larista. Okay. Larista. Ips. Philo-Ra S. Philo-Ra S. Philo-1. Could not find function. Okay, yep, that's good. Make it. Some labels not encountered in Phi. Okay, did I miss? Spell something? Okay, let's just say it's Grandis instead. Since I cannot. We are using that same format. I'm pretty sure these are just, I just need to multiply something, but I really want to double check. Unfortunately, these phylogenies are fucking huge. It is underscores. Damn it. Okay. So now we have Philo-1. Okay, plot Philo-1. Edge labels. No. That's not what I wanted. Edges. Edges. Oh my god. Okay. Plot edge lengths ape. No, it's not plotting it. It's I want to show tip label, show node label. just the branch lengths. Okay, plot. Annotating trees. So just scroll till I see something that looks about what I want. New. I just want to double check that this is all right. Outer margin. Okay. This is driving me fucking crazy.
You're crazy.
So. Oh, okay, wait. Edge. Edge labels. Text. Philo 1. Ha! Okay, got it. Got what I needed. Well, it's not too awful. Yeah. CX is equal to 0.5 to show.
The guessing.
Okay, I need to first change this to plot.philo, and then it's okay. So then I know on this split. Okay, wait. Oh, fuck. Okay. Wait. Okay, wait, no, I need to look at the supplementary material that I was viewing. Okay.
Imps.
Fuck. Oh, wait.
What the hell is the file EPS?
What?
Do you know EPS?
What about it?
Do you know what file type that is?
No.
Okay, me neither. Just wondering.
Fuck, what are these units in? Like, legit, what the fuck are these units?
Vector file format. For image printing, bro?
Yeah, so what fucking units am I using here? What units am I doing? I'm so confused. Okay. 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 So, inputs, I have this tree file. Let's start off with the squamate shapefile. Okay, let's open this up. Okay. Like, I just want to know the units of the length. Okay, open with, let's open you with Sublime.
I can't open up a figure because
Yeah, I'm just like, what is the fucking unit here? That's all I'm struggling with. Because this is the actual phylogeny, but the tree file, like, what are these edge lengths? Okay, wait. That's disgusting. there a different tree, maybe? No, these are all millions of years. Regardless, it's wrong. But how... Okay, let's read these. Let's see what these are saying. No. Okay. So here's S1. Okay, so it's not substitutions. What is this one? This one is our age estimates. Millions of years. $25.42 and 23. Then the next one. Wait. So that one would be. Okay, I need to do a smaller sample. Okay, let's do it with. Okay, Bellatorius Freyi. And Lyophilus Kinteri. Oh, wait a second. Where the fuck is this? Okay, wait. Let's do show tip labels equal to true. Was I looking at the wrong things the whole time? Coventry? Where the fuck is that? What the fuck is it? Fulcara. Excuse me, why are these relationships different? Why does my... What? Why does this phylogeny have different relationships? Wait. Is this the right paper? Is this the right paper, bro? Is this the right fucking phylogeny? Should be the right phylogeny on this side. Oh my god, wait. Oh my god. There's a different paper that I'm looking at. Oh my god, wait. Squamate phylogeny. Hold on, wait. Am I using the Pyron dataset? Did I have that one downloaded? Oh, what's up, Ocean Caroline? How's it going? I'm trying to resolve a taxonomic mystery that I'm running into. And I'm a little bit unsure.
Do you have Adobe Illustrator?
No, but you can get it for free. You're at the school. Pretty sure, anyways. Oh my gosh. Oh, look, a dating online. Oh gosh, that's so
He's
weird.
looking for hot singles in his area.
Hot singles, hot lonely they need to be lonely.
They need to.
It's the only way
no
they'll show
requirement.
me love. Hey, what's up, babe?
Do you come here often? Terrible night almost.
Okay, I'm gonna re-download this one.
God bless.
I'm really confused because the numbers are just not adding up, and I'm just very confused as to why they're not adding up.
Classic.
Yep. Like, I don't think it's any. No, wait, this is just the Philip file. Let's see, what does it look like? I mean, it's just the data matrix, but I want the tree. Yeah. I mean, wait, wasn't there a direct tree download? Let me just check out Treebase really quick. I'm just so confused because I thought I downloaded the Zhang and Weens dataset, but I'm not sure now. Like, now I'm just like, it's been such a long time. So trees, squamate. Oh god, I went to full screen. Never go full screen. Okay. So... But now I don't know where I got this from.
Your follower just said that they just had an exam on Squamate.
Archosaurus. This looks like a blast. Oh yeah, I'm having so much fun. I'm making good progress, but I'm a little confused as to which data set I actually have because I've been using it for so long that I just have this one, Squamate SHL. It should be... I got rid of my... Squamate SHL. SHL? Oh god, I don't know if that's gonna help me out. What does SHL mean? I wrote this to myself. Oh god. Oh god, I should know this. It's not this Simone one. No, Simoes? Simoes. Because this isn't a full phylogeny. I have it on there that I did Zhang and Weens, but I'm just like doubting it right now because of how funky those...
Your advisor up on there?
Well, yeah, like, that shouldn't be that surprising.
That's true, he's an old guy.
The paper was published in 2015, dude. What are you talking about?
He's an ancient old man. Just kidding.
Okay.
I have to put in a software request in order to get
We'll just pirate it. I don't know. Hold on. Okay, let's go to Google Scholar then and jump into this because I am terribly confused. Because it should be this paper. So then... But I downloaded a tree file. Not a Philip file.
Philip?
Whatever.
Do you call him Philip?
I call it Philip.
I call him Philip.
Why? It's supposed to be Philip.
No.
It is to me.
What's that website that you use for getting articles without needing to log in?
Sci-Hub.
Sci-Hub.
Yeah. Okay, it's not, unless it is substitutions per site. Oh, full species tree is shown and available in Appendix S2.
Duh.
It's in Newick format, right? Because that's what I was wanting. Okay. Okay, here it is. But, okay, well, I'm sorry. Here it is. Yeah, so these are the squamates. Hooray. This looks so good. Yay.
Love that for you.
Yep. Love it. Love it. The only thing... They need a scientist version of Dumb Ways to Die, but instead all espressors that make people go crazy. 1,000 ways to burn out. Like
That hurts.
That hurts.
God.
75 of those are just this. What unit is this? Okay.
Didn't you say it was a new one?
No, but the units of the actual
right.
numbers. Bro.
It's the same deal.
Bro, I've been using the
Time
wrong
out,
phylogeny.
Dylan.
I've been using the wrong phylogeny for 3 years. Not really. Okay, but wait. Now I'm having a moment.
So now it's saying it in years, but it doesn't.
Millions of years.
Oh.
Which is what I wanted.
Mm-hmm.
The thing is, here's what's getting me. My amphibian one and my squamate one. Holy shit. To be fair, the amphibians and the squamate ones are on the same scale. They're both a maximum likelihood, but
Right.
but it's not percentage. That's not what this is showing.
Mm-hmm.
Yeah. It is like distance. So it's still fine, but now I'm like, do I use, oh god, now I'm having a moment of if it's proper to use millions of years of divergence as your evolutionary distance. I don't think it is.
I literally don't even know.
Because that's what the phylogeny is showing, but if you have it like millions of years... Do you see what I'm getting at? Do you see what I'm getting at? So it's like I have two phylogenies here, right?
Mm-hmm.
So this one, the time calibrated one, is it in millions of years. Like that's just So if I want to calculate phylogenetic diversity over this, for example, you wouldn't, because the branch lengths are not millions of years.
Right.
You see what I'm saying?
Yeah, it's not corresponding.
Right. But
Right, because time is also kind of the metric for, I mean, however many mutations can happen over time since divergence.
Yeah. So I have not been using the wrong phylogeny. I used the wrong, but...
It's the metrics.
Well, okay, hold on. I'm going back to the grafting thing, okay? Because they were able to graft it just based on millions of years. But they used, I want to say, okay. So they used the time-calibrated phylogeny, which is good. And then for amphibians, I used a configured time tree from PhyloOrchid that was constructed using the Alfaro et al. Time tree as the reference and the Pyren et al. As the target. So Pyren and Wanes is the phylogeny I am using for amphibians. No, I'm not using the wrong one. Okay, I was just like, shit. But then how do I graft them while maintaining... Hold on. I'm just gonna look up something. Okay, phylogenetic. Like, I'm really having a moment. Over a time-calibrated phylogeny. Yeah, you use branch lengths. Okay, here we go. Some sentence. I'm just like, I just need like a sanity check to make sure I'm not missing something really fundamental. Because it is a proxy in some way. Oh, but wait a second. A lot of these metrics assume a neutral model of evolution.
Right.
So you can use time. Right? Because you're assuming they're all evolving similarly.
And that most of the mutations are not going to be advantageous or deleterious, just neutral.
No, wait. Sorry. No, you would no. I would assume a clock-like model of evolution.
Oh, okay, molecular clock.
Sorry, yeah, molecular clock-like evolution, where greater time means greater divergence in a 1-to-1 ratio.
Right. Okay.
Right, you see what I'm saying? Like, that just clicked for me. Like that concept just clicked for me. So, hold on. So does, since this is phylogenetic diversity, assume clock. Hey, I mean, we can get it straight from Daniel Faith himself. Some of the lengths of branches. Formative. Okay. Yep. Like I think this is proper, but I think I'm missing something major as well.
Hard topics. Sorry.
Right. But then like, I'm just trying to find. Because you would not do it over. Okay, hold on. Let me see what they're using in their methods. Okay. All edges. The types of restrictions that two will be useful. Okay, wait. Let's go back even more fundamental. What is a branch length phylogenetics? Okay, we'll start here. Right, see, this is what I'm used to.
Yeah.
Yeah. Informative. Okay. Relating distance, rate, and time. Hold on. Okay.
Is it clicking?
This equation made it click. The amount of change is just the evolutionary rate times the divergence rate.
Yeah.
Right? But so that means if I have a time-calibrated phylogeny, I can change the genetic change based on that. You see what I'm saying? You see it? If we know the divergence times, and if you know the evolutionary rate,
right,
you can multiply it, and that will give you
substitution
the actual change.
Right.
So where does one learn to create your own phylogenetic trees and modify them? We only had one lab with Mega.
That's fair.
That's fair.
It's kind of what I'm doing.
yeah. I mean, realistically, there's actually a lot of really good free guides though. A lot. I mean, I literally Google how to do all of this. And there's a lot on there. Yeah. Okay. So I think I know the route I need to do. So but yeah, a lot of it was learned. I prefer Mega makes it Mega makes it easy, but also really complicated and confusing. Maybe confusing is better.
And Mega's just janky.
Yeah, Mega's janky. Mega's kind of trash, honestly. Yeah, so I do all my stuff in R, but I also use a lot of command line stuff. That's just kind of how phylogenies are still built, is all through command line. With a few exceptions nowadays. I've used POP, I've used IQ Tree, I use Cypress. A lot of it is Felsenstein's book, Inferring Phylogenies, is really helpful.
Is that what you had to read?
Yeah, that's what you're gonna have to read.
That's what I'm gonna have to read. Do you have the PDF?
Yeah.
Yeah. I'm gonna need that.
Because a lot of it is just theory. I mean, at the end of the day, if you don't care that much about making a great phylogeny, you just want to get one done, the basic process is to get genetic data, align it, and then run something like maximum likelihood, or
any of the kinds of substitution models.
There's so many different things you can do. That's kind of the problem.
Yeah.
But a lot of them are making it pretty easy. Pretty fucking easy. Yeah, if you're using Mega, you just upload the data, click make a maximum likelihood phylogeny, and boom.
Yeah, and you can choose different kinds of methods.
Yeah. It's kind of there's not that many steps, but within each step there's so much variety. That's what causes the issues. Yeah. Okay, so I need to see if they actually specify any type of evolutionary rate. That's what I need to look for. What if you only have morpho species? So that is also fine. You would actually do more of a parsimony-based approach with that. Parsimony just means simplest. If you have morphology, the data being fed in, you'll still have I'm trying to think of how to put this. Basically you'd have if we imagine this is an Excel sheet or whatever, we can actually show this really quick. If we imagine an Excel sheet, I'll zoom in on it a little bit. Let's say we have a species column, and it's just A, B, C, D, E, F, G, H, I, J, K, L, whatever. And then each new column would be something akin to a morphology trait, right? Yeah. You have to check how you're doing it, because some things will only accept character data or factorable data.
Right.
Others will accept continuous and factorable data. So what I mean by that is if we have some common things like length, let's say color and region, like just go with that. Length would be like, 1, 2, 1, let's do 1.1, add in some things, 1.2, like just various different, like numbers basically. And you'd have it for every species, or best you can. I'm being very lazy with this, obviously. Color could also be, like, of course, like blue, red, whatever. You can have as many of these as you need to. And then region would also be the same. I'm just going to call them region A, region B, region C. So basically, if your parsimony approach does not accept numbers, which does happen, like they won't accept continuous values like this, you would have to make them into different categories. So, the category could be small, medium, large, but you'd probably... Yeah, but it depends on how many bins you want to make, yeah. I mean, more bins is better, but then it makes things more complicated and can run longer. It depends on your data set. Nowadays, though, things can move very fast, so it's probably not that big of a deal, and there's probably are programs that allow you to do both of these. I just don't know any off the top of my head because I just work with pure genetic data, which...
Mesquite you can use.
Mesquite, okay.
I want to go old.
I mean, Mesquite's a standard still. It's still used. Like, it's still good. I mean, I've actually never used it, but...
I've used it once for a lab. For evolution.
Yeah, exactly. But yeah, so it's really just about getting your data into some type of format like this, where it's like species A, species B, species C, and then putting into something. If you're not running with genetic data, it's usually this type of input. Usually with morphological data, it's this type of input. So, yeah. Okay, but they estimated trees, scaled, relaxed clock model.
Huh.
Okay, wait. Relaxed clock model, what does that mean? Here, we can look at the beast documentation. So, strict, of course, is just a single value. Relaxed, I think it means each branch to have its own clock length rate.
Oh, yeah.
Yeah.
I can get complicated.
Yeah. Phylogenies are kind of a beast to handle, truthfully. So it's all about it's just a lot of theory that goes into making a good one, and that's kind of where I'm stuck in right now. Like, that's why I'm like, wait a second, does this mean that? Like, what would it be? What would the branch length be between amphibians and reptiles? Like, that's the kicker. What is that branch length? What is that edge length?
I mean, to me, it would make the most sense it'd be time.
Right, but that's not a branch length. I mean, we've gotten to the point where now I'm not doing that. Like, it's not... I mean, I can graft the two time-calibrated phylogenies together, but then I'm unable to convert them because they're using a relaxed clock model. Because it's each branch length. So I would have to re-estimate it.
Google.
Yeah.
Ooh.
Okay, so wait. How would I estimate it? Okay, how would I estimate the time between the two? So, I believe, what did Zhang and Wines do? They did American Herbs. They did a taken from fossils and estimated data. tree PL? What does tree PL mean? Phylogenetic generalized likelihood. For large phylogenies. Okay. Quick run, what do I need? The basic things are tree file and a config file. This is the most basic form, would look like this. Okay. The most recent common ancestor should be in the form name, taxon 1, taxon 2, with the constraints being so, but does this one give it a clock model? Oh, this is a quick run. Okay, hold on. Run options. Run options. Okay. Okay. So. Well, I mean, I guess one option is to convert the years that I have into a base evolutionary rate, which I... Oh, hold on. When did Amphibia and Squamata diverge? So, okay, wait. Evolutionary rate of tetrapods. So I would just need to split them out at different rates. Do you see what I'm saying? So I can take, basically what I'm thinking is, I can take these values right here, where these are in millions of years,
Right.
and assume, wait. Why don't I just take the average of the two? The average evolutionary rate of 1. Because there are standard evolutionary rates.
Right.
So these are tetrapods, speciation rate. Like there are I see it now. A lot of things just connected all at once. Like I understood each thing in a vacuum, but it just now clicked. Okay, wait. I want to see. Yeah, I want to see. I just want a number to run with. In the genomic era. Oh. Okay, genome size, contigs, speciation, link. But what is the? Oh, that's just reference genomes. just want a number. I think I have a good number in mind, but I just want to be sure. I just want to be sure of this. Oh god. I think the number is going to be around 0.2. And I'm just not even seeing numbers, so... Comparative substitution rates. Right, that's what we're operating with. Okay, one, I need to just close up a bunch of things. Hold on, because this is getting unwieldy. Okay, I don't need this, don't need this, don't need this, don't need this, do not need that, do not need that. I'll keep that open. Do not need that, do not need that. Keep that open. Do not need this, do not need this. Do not need this. Do not need this. Do not need this. Tree-wide diversification rates. Okay. ED, evolutionary distinct, conservation, geographic, phylogeny. Yeah. I have a median. Variation in evolutionary distance. Okay. Wait, what is net diversification rates? Okay. The lower rate of increase. Consistently high. I see. So supplemental figures 2 through 8. That's what I need to see. It's over here. Supplemental figures. So these are still S1. Oh, I see. Okay, supplemental figure. Okay. Let's look at table S1. I just want a rough value to work with. And then, okay, you know what I'm gonna do? I'm going to say divided by substitution rate. And then I'm going to say substitution rate is equal to 0.01. Wait, if I divide it, these are the divergence times. Okay, wait. Okay, so all the values I got is substitutions per site. So I have the genetic change. I have divergence times But here I get net diversification rate. These are amphibians. These are squamates. Okay. The question then, diversification rate I think we can assume is the same thing as evolutionary rate. Right?
Diversification times the same thing.
So I have, wait, here I have, okay, yeah, substitutions per site, not per year. So I have, okay, I have genetic change. Oh, these terms are so confusing. Okay, so I have, okay, genetic change is visible here, but we're talking about the rate of evolution hither. So again, okay, but, oh, right, my Word documents. So maximum likelihood, what are these values? Okay, maximum likelihood values.
Portion.
Values for length. That's what they're giving me. Oh, phylogeny. Ooh. Always gotta, you know. Like, I'm having a major moment of, like, what is that value? So if we do pop, yeah, because these are not maximum likelihood values. Understanding the trees block, the final pop block, the trees block, tree description, keyword, the branch length. See, it's just like, I just want a unit. I just want a unit. Expected number of substitutions. Okay, so if you're building a tree with length, why not just look up what is branch length proportion to? Because it would be then the genetic change, because it wouldn't make sense that your branch length would be the rate. So if this paper is saying net diversification rate, that would be substitutions per site per year. Yes, okay, yes. Sorry, I needed to do a super long change. Make it like, wait, I don't divide it, I multiply it by the substitution rate that I'm deciding on, which is going to be 0.07, because these are hovering around there, time before present, and they're a lot higher back then. But what I can do is I can run this at multiple
Substitution rates.
Right. So, okay. So, I'm gonna load this in. load that. I'm gonna do this, 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 do this. Oh god, it's gonna look really bad. Tip dot labels equals false. I need to redo everything. It's show.tip.label. Because also, if we're looking at the, I need to find the time calibrated phylogeny. This will give us a better idea of what it should kind of look like. So this one is time calibrated. Let's look at one of the older clades. So this one. Here, so Xanthusida, yeah, so that goes back to 157. Okay, I think it's a lot better now. Okay. This is a lot shorter than it was. And then, let's say we want to show axis phyllo. You can actually make out things now. Axis phyllo. No, wait. So okay. Does that make sense? So wait, we got plot. Okay, we got plot, class, tree. Okay, axis, phyllo. What am I doing? Axis, phyllo. So that's the rate that we have here. No, that didn't work. Wait, why didn't that work though? Okay, wait. What? So babe, okay, look at this.
Squam, amphibians, amphibiancy.
Anurans and caudates, Sicilians. My thought would be that the trees would start here, here, and here. However, axis is the same, so there's like an ultra long route. This edge it's like adding them onto the end.
Yeah.
No. Actually, no, it's not. It just has very long roots.
Mm-hmm.
But why? I've dropped.
Are humans your outgroup?
In amphibians. drop them for the grafting. But this should be down here. This should be up here, like down here. It shouldn't be like this many years, but like, because it is changing. It is saying that this branch length. So what I think I need, 5 to 3, 5 to 2, 4 to 5, 4. So, I think this needs to be 0. This branch length is fine. But then this branch length also needs to be 0. Split age is inconsistent. Okay, let's not make them 0. Let's make them 1. Yeah, right. Split age is inconsistent with edge lengths in phi. Class tree. Yeah, I'm really confused by this. Okay, split age is inconsistent with edge lengths. Oh, God, okay. Yeah. But... Oh. Okay, no. So that's not it. But it's not... It's still pushing them at the end. And saying, like, all the diversification is here. Which is better than it was, but... If... I mean, because... Why is it such a long branch? Like, I understand it's supposed to be in millions of years. Is 0.07 maybe not right? Is it supposed to be like, did I do a dumb? Unlike... I don't think so. My phone making noise. I need to be dropping off forms pretty soon. That's why I haven't started like smoking. Nope. It looks more right. But I don't know if it is. So I got the 0.07 number for substitutions per site. Wait. Oh, wait, no. Oh my god, diversification rates of speed. I was literally just looking for this. Like... Oh my god, okay, okay. Yeah, it's OOs. Okay. Okay, here we go. Here we go. Let us find, okay. Average diversification rates, view in line, okay. Family level, what? Wait.
Yeah, what?
Right, what? How does that... Is this like a weird... It must be how things are grouped, you know, like a weird thing like that.
Mm-hmm.
Okay, but I want to see all data are available in the electronic supplementary material. Well, excuse me, but where is that? Haha, where is it? Okay, are they in the triad? Okay, why doesn't it go directly to that? Okay, oh, it's right there. Duh. Okay, so now I'm gonna follow this. Oh god, why did I click that? Okay, never mind. I want the data. I want the data though. I don't want the paper. I want the data. Bro, am
How many
I?
times can you repeat it?
I know. I'm just like, it's like. When did we... Cool, just so I can kind of plan out my day. Okay. Wait. Electronic supplementary material is available hither.
Just like that.
I went... Why the fuck? It's not there. It's back on the original thing. Okay. Okay. Fucking stupid. Okay. Now I can get it. Wow. Okay. Kingdom. You jump straight. Okay. Orders. Classes. Class AVs. There we go. Okay. So, Amphibia. Bitch, don't give me 3 fucking... okay, I'm just going to say 0.0299. So, we're going to say 0.03. I'm just going to go with 0.03 for Amphibia. And then... Where the fuck are the... Okay, Desiree. I can sing by sometime tomorrow if that works. We're not doing anything tomorrow, right?
I got school.
Oh. Is that your long day?
No, I don't have a long day this week, thankfully. My classes were canceled because it's Veterans Day on Friday.
God bless the troops.
I know, one of my students told me that, and I was like, damn, I gotta call my dad.
Okay, you know what? I'm just going to go with 0.03 or wait, sorry, point.
Yeah.
Why is it 0.03? No, I'm saying that because. Okay, now I can also start smoking to relax. But no, I'm confused. Okay. Diversification rates is exactly speciation minus extinction. So these are diversification rates. Okay, not net. These are just diversification rates. We're going to go with 0.03 and stop asking so many questions. Why are you asking so many questions? Let's see what it looks like. Good lord. That doesn't feel right. Okay, so I can look at this. Let's see what it looks like on the amphibian phylogeny. Let's see, amphibian phylogeny. Oh, see, millions of years. Evolutionary distance in millions of years, but that's not what I want. Dun, 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 dun. She answered it. Figure 2.
What should we do about food?
I don't know. You had a call for a second.
I know.
Okay, I figured. I just don't understand what to do. Because the problem is, okay, so the problem is compounding. So basically, these are supposed to be diversification rates, not millions of years. So distance. This doesn't feel right. Because this one, I specified this here. And so if we were going to plot Phylora A with that same axis, show dot tip dot labels label equals see, this is probably the Sicilians down here. Just see if I can make out a single tip label. No. But you see, they only differ by a little bit. They have a net diversification, like a change of 0.01, 0.02. But I know edge lengths. So many of them that are above 1. I'm just so confused. Let me look at down into the orders. Or families. Cecilidae maybe has a weird one. Maybe I can go based off of that. Why ain't you sorting this shit? Okay, so Cecilidae is around 0.05, 0.06. Diversification rate. But there's 33 million years between them. Go to orders, look for Gymno. .03 again. I'm like really struggling with this.
Yeah.
The substitution rate is this substitutions site these are such terrible file names. Okay. So this one, these are the bootstrap values. These are all bootstraps. These right here, 0.2 substitutions per site. So this whole thing is 0.2. This 0.2 is the total genetic change, which would mean why don't you give me a scale? Okay, let's go down to Skinkaday. 1 substitutions per site. So over this, let's say it is
Guess what the name is for a tomato?
I can't right now. I'm really trying to focus on really out there numbers. Just give me a second. Amphibian squamates. think I have a great idea. I'm gonna stop streaming because my brain is fried,
Yeah, I'm like, I was sensing it.
and I'm just not sure what to do. I think I know the correct answer, but I wanna not do it, so I need to stop